Hello everybody. In this video we will detect flooded areas using SAR data from Sentinel-1. To do this, we will use the platform Google Earth Engine. This is the graphical user interface of Google Earth Engine. Here we will develop the code that will be launched, and this code must be written in JavaScript language. So the first step is to draw a study area where we want to generate the map with the flooded areas. To do that, we click on this icon and we draw the polygon. Now we can modify the name of the layer by clicking on this icon. Write, for example, study area and accept. Next, this code line will center the map at the study area. Then we must import the library with Sentinel-1 images. To do that, you just must write here Sentinel-1. This is the dataset we want to import. We can change the name of the imported dataset that we will work with. To carry out this study, we will need some images before the flooding event and some images after the flooding event. So, knowing the area where the flooding happened, we also need to know the date. Therefore, for the images before the event, we just must filter by the dates, study area, the instrument mode as IW. Also, we will only use the descending trajectory. Here, we will use two polarizations, vertical-vertical and vertical-horizontal. Finally, as several images can fulfill these conditions, we calculate one resulting image as the median at the pixel level of all these images. We do the same thing for the date interval after the flooding event. After that, we show the image on the map by representing the vertical horizontal polarization. Clipped by the study area, we set the minimum and maximum values, and we write a title for the layer. We do the same thing for the image after the flooding event. Then, to minimize the speckle effect, we apply a focal median filter, which size will be 50 meters, and the shape of this filter will be a circle. We must do that for the image before the event and after the event. We can show on the map these images filtered by the median filter. In the next step, we merge both images before and after the flooding into one image. All these four bands, two bands from image before the event and two bands for the image after the event, form the resulting image. Then we rename these four bands. This four-band image can be visualized using different combinations of RGB. After writing these code lines, we can click on the Run button to show the generated images on the map. Here we can observe the different layers corresponding to the different visualizations we carried out. For example, the original image before the flooding, after the flooding, filter to reduce the speckle noise, and the combination of bands from the image before and after the flooding. The flooded areas are represented in red color. The detection of flooded areas can be done by using several methods. One of these is setting a threshold estimated by a histogram. To do that, we need to quantify the differences in SAR image by calculating the difference between the image after the event and the image before the event. Then, the resulting image can be visualized using a palette of colors, where blue colors will identify lower values correlated with a bigger difference in the polarization between both images, and white values will represent lower differences. Here we can observe the resulting image showing the differences. To generate the histogram, we need to select new samples for flooded and no flooded areas to generate this histogram. Better differentiate these areas, we can use the generated images. Firstly, we uncheck the study area layer for better visualization, and then we create a new layer for flooded areas and another layer for no flooded areas. We select the polygons and we change the names. This is just an example of how to select these samples. However, a higher number of samples should be selected. The next step consists of clipping the difference image according to the polygons representing flooded and no flooded areas. Afterward, these two clipped images are merged as different bands into a single image, one band representing flooded areas and the other representing no flooded areas. Then we rename the bands. By using this image, we can generate the histogram differentiating these two classes. And we launch the code. What we can see in blue on the left of the histogram are the areas representing flooded samples, and in red on the right of the histogram, areas represented no flooded samples. To select the threshold to differentiate both classes, we must observe where, more or less, both histograms will intersect, considering them as a Gaussian distribution. We can assume that the intersection is at -1.5. The next step is to generate a binary image from the difference one and assign a value of 1 to all the pixels below -1.5, so that these pixels will be represented as flooded. And if we launch the code, this is the result of the binary image using the histogram threshold.